Hello, I'm Norm Marshall, and this presentation explains why freeway expansion studies show false benefits. This presentation is number 3 in a series of 6 that can stand alone but also tell a larger story together. In the first 2 presentations about why freeway expansion does not reduce congestion and 80 years of failure in reducing congestion by expanding freeways. In both cases, I mentioned that bad computer models are cause of these problems. This presentation digs into that problem. Before we can really talk about modeling, we need to understand what we're modeling, and that brings us into traffic data. And this will start out looking a bit confusing, but I'm going to take time to break it down, hopefully in a way that's understandable. What we're looking at here is a lot of real-time traffic data collected in California from freeways, and along the vertical axis on the left we have speeds ranging from 0 miles per hour to 80, and along the other axis we have vehicles per lane per hour. So freeways have different numbers of lanes, but we can sort of get an apples to apples comparison by dividing by the number of lanes, and you'll see there that we can get up to around 2,000 or somewhat higher, 2,300 in a few cases, vehicles per lane per hour. And the data is pretty complex, so let's look at it in sections. The highlighted box shows the observations for traffic of less than 1,000 vehicles per lane per hour. These are the conditions that we could call free-flowing, and we have free-flowing speeds in most cases. For the few observations where we don't, we probably have accidents or fog or some other condition. And it's good to know that this happens, but of course these observations aren't really very important for planning if we didn't have, because it's not congested. At the other extreme, we have observations above 2,000 vehicles per lane per hour, and these are uncommon. The reason is that extremely high traffic densities can exist for short time periods, but any perturbation in traffic tends to cause backups, and it sort of falls apart very quickly, and many of us have experienced something like that. So this is not a sustainable traffic flow, so this isn't useful for planning either, except as to be something to be avoided. So the area that we are of interest for planning is really this range between 1,000 and 2,000, and we really don't see much of a pattern here. The speeds range all over the place. The slow data points in this area result primarily from downstream bottlenecks, which include off-ramps, on-ramps, merge areas, and lane drops. And so really, if we're just looking at one segment like this, we cannot predict the speed based on the volume because we're not able to look downstream and see what's going on. And this provides a good introduction to why there's a fatal flaw in the regional transportation models that are used to plan freeway expansion. When the models were developed 50 years ago, regional transportation modeling was so computer intensive that we needed to simplify the models a lot to get computers to work with them at all. And so a simplifying assumption was made that you could estimate the travel speed for each road segment based only on the traffic volume for that segment and ignored all the bottlenecks. And this critical step has never been updated. And this is a fatal flaw in freeway analysis because most freeway delay occurs behind bottlenecks. So this is the model that's used in the study of the freeway expansion that went with that data we were showing. So the model assumes that under 1,500 vehicles per lane per hour we'll have a high speed, 70, which is the posted speed limit. And above 2,500 vehicles per hour we'll have a very low speed. Now those of you may remember that there weren't any observations above 2,500 vehicles per lane per hour. And then in between we have this curve. So if we lay this curve on top of the data, it doesn't match well at all. It's very bad throughout the critical range of 1,000 to 2,000 vehicles per lane per hour. And it's even worse for greater than 2,000 because it doesn't constrain the traffic volumes to realistic levels. So both the data and the model were taken from the I-405 expansion in Orange County, California, environmental impact statement. This is a $1.8 billion expansion project where construction began early in 2018. And now I'm going to show some other slides made from the information, the environmental impact statement. For the base conditions, which in this case were a model year of 2009, and then for both the no build and build conditions in 2040. So in 2009, the model appears to overestimate the base year volumes. This is the most congested segment in this corridor. We have data segment by segment, but it looks like they're forecasting somewhat more traffic than's really there. This is probably because often there's some sort of adjustments made to the counts to make sure they're really capturing the worst conditions. So they probably adjusted it into an area that's not even happening. But when we look at the future, things get really crazy. So the environmental impact statement says if nothing's done, we're going to have on this segment over 3,000 vehicles per lane per hour, which of course has never been observed despite California drivers daily trying to push as many cars as they can. And then if we build the expansion, then we'll reduce this to under 3,000, but still more cars per hour than have ever been observed. Based on those nonsensical traffic volumes and speeds shown in the previous slides, the EIS is forecasting that if we do not do the expansion, the vehicle hours of delay will increase by a factor of 21 between 2009 and 2040, but increase by only a factor of 3 with the expansion. Both those factors of 21 and 3 are nonsensical. They make no sense based on what's possible in traffic. How can the analyses be so bad? I'm still somewhat puzzled by that too, that other people haven't noticed this and tried to correct it. But here's some possible partial explanations. One is this is the way it always has been done, and people haven't really looked closely enough at what it means. Another factor is that large investments have been made in hardware, software, and training. And in less congested areas in Los Angeles, sometimes the model problems are less obvious, although they're still present. And there's also a disconnect between the modelers, who often are somewhat aware of the limitations of the models, and the decision makers, who tend to accept the forecasts as more valid than they are. But more cynically, there's large fees collected for doing it this way, and these methods always justify freeway expansion. And fixing the studies would cast doubt on past studies as well as current studies. This presentation is the third of 6 on freeway capacity and congestion. The first 2 describe why freeway expansion does not reduce congestion and showed examples of cases where freeway expansion had not reduced congestion. This presentation has delved into why the computer models always show benefits that do not get realized. In the next presentation, we'll look at how the modeling problems can be fixed. This is Norm Marshall. Thank you for watching and listening.